Okay, I think we're already 50%, 50+%. Our class is already over. So I would like to kind of recap about what happened already and what's going to happen at the end. So we already done homework 1, homework 2. I sent out a message based on all the feedback I got from all of you. Thank you for those who talked to me over my office hour, and then we actually I kind of summarized the most critical issue which I want to clarify. So in that document I released earlier today. So I already get my homework 3 and homework 4 ready. I haven't actually uploaded to all 3. It's always a headache for me to have to do everything 3 times. And so I will do it after the class, but I will show you what it looks like for homework 3 and homework 4. So this is the schedule I want to tell you. For homework 3, this will be my main content. I'm going to talk about this for both first and second session. It's about, you already done Little Red Riding Hood, and then you already done dump to JSON, assuming you did it correctly. And essentially, homework 2 is extending from your own code in homework 2 and adding another function called JSON to object. So essentially, you can think about this is from a C++ object, you actually reproduce a JSON string which represent the content of the object. That's actually dumped to JSON, which some of you already did for homework 2. And JSON to object is that, okay, I'm actually getting a JSON. Maybe it's actually from output of your homework 2, but it may be somebody just handcrafted and somebody maybe write a Python program to build an object in Python object, and they also have a dump to JSON, and then they actually produce a JSON format. So now this function is you are going to take that JSON string and convert it back to the C++. So essentially, you have a two-way street. If you have a two-way street, you can do a lot with that. I mean, for example, if I have a two-way, I can actually, let me give you an example. I have a C++ object here. I convert it to JSON, and I send it using JSON RPC to the other part of the world. And when that particular server receives it, they actually call JSON to object. They actually convert it back to the C++ object. So essentially, if that object represents a person, then what you just did is move a person from one corner of the world to the other corner of the world. So this is called object mobility. You can actually mobile. And you can also do this. You can convert it, what you did, in JSON. And what you did is you save to a file. That's actually the thing I want to tell you. How do you actually save things to the file? You already deal with a lot of file stuff for homework 1, but file is so fundamental to programmer because it represents persistency. Because once you turn off, I mean, right now, if you write a C++ program or Python program, when you kill the program or the program crash, or the power is gone, then essentially your object is gone. But if you actually use your homework 2, you produce that JSON, and then you save it in a file. And now the program is gone, but what you did is you actually run the program again, you actually read the file, just like the way you read solution.txt, and then you call the function you just wrote in homework 3 called JSON to object. You actually convert that JSON back to the real object from whatever it crashed. So this is the other concept called persistent object. So it's essentially the object is no longer transient. The object is actually persistent. With these 2 functions, in fact, you can have a lot of interesting application. I will actually gradually share with more of that. And that is a subject I'm going to focus today about how do you actually do the other part to convert JSON to C++ object instead of convert C++ object to JSON. Okay, so then you're going to do your midterm. Just remind you that's November 4th, which if you missed the lecture, you should really look at that lecture and we can talk about that. And then after that, homework 4. Homework 4 is supposed to be really light. And I have a video. I want this is take a break. Okay, so this is, you can see the deadline is really, really, really close to the homework 3, but it's really, you should be able to get it done within like 30 minutes. If you actually just follow the instruction carefully, it should be really trivial. So that is basically for you to be able to tell about a little bit about pointer, about how you can show the virtual inheritance is different from multiple inheritance. I want to make sure you actually know the difference. But the next one is interesting, is going to be something I call a JSON RPC CPP, which I start talking about that. That's going to be homework assignment number 5. So one thing I'm expecting that by this time, why I introduced you earlier, because I want to make sure you get your JSON RPC CPP installed first. And when we get to that point, that we're going to just implement something very simple. So this one is homework 5 is really for preparation for homework 6. So homework 5 is essentially, I'm not expecting you to do too much other than extending a little bit than what I showed you last time for the lecture in October 24. This part is really just make sure you have a runtime environment for JSON RPC, and you know how to actually make a function call, remote function call for some of the program maybe you already did, like an LRH kind of thing. So that's actually going to be simple. But okay, by the way, over here you can see I put inside the bracket means number of student. So essentially your homework 2 is 2 people, homework 2 student, homework 3 is 2 student, homework 4 is going to be 1 student. It's really too simple, doesn't make sense or whatever. But homework 5, you start to learn to build the JSON RPC. I know if you've never done any kind of like distributed web-based programming, there is a learning curve there. So I want to kind of give you a heads up about what's going on. But this one is going to be group. This is going to be the same group for you to do your final project as well. Okay, this is going to be the group. So homework 6 is going to be, I will call it a major one, but hopefully it's a fun one. Okay, I want to have a fun one. What do I mean by a fun one? You're using JSON RPC, using all this nugget you learned earlier to do this, to do what? To do Wordle. So what is a Wordle? Wordle, in homework assignment number 1, Wordle is a challenge of a secret 5-letter words, and you're going to provide a guess. If you guess right, then you win, right? So you're kind of learning about how do I do automatically come up with an answer for the Wordle. So this one is going to be like this. I'm going to have a server. This is going to be a server of a Wordle server. So basically, I'm the only one who actually have the right word. And the thing is that the protocol is that your program is going to do pretty much similar to the first one, except we're going to separate the server part and the client part. So your program, by the way, you're going to develop this in team, is going to make a request to the server saying that, hey, I want to play a game, send me a game. So the server is going to have multiple games. So when you make a request, the server is going to randomly select one and send it to you. So the first time you actually got one just has a game sequence number, ID number. Okay, only the server knows what's the solution to that corresponding to the ID number. Okay. And when you get at the first group, this has to be automatically. You can actually play against server manually, but your final submission has to be, what do I call it, fully automatic, autonomous. So what you will do is that you're going to guess a word. So how do I guess a word? You actually include a JSON key value pair, say, guess, this is a high-level word I like to guess, and what's your ID? I mean, you can create a game and say, I'm a Pikachu, or I'm Lord of the Ring, whatever you want to choose. You pick your name so we know who actually provided the guess. So you actually send the name, you send the guess. When the server received it, and the server is going to actually attach to your record, also in JSON, about the result, like the pound sign, underscore, or O, those kind of things, so show the result. So guess what? This program just keep going, and everybody is submitting their result. So basically, for example, you came in at 8 o'clock, and you realize that the server actually give you a record, which is that already have a 10 student already submit their word, not just about their word, but also about their result. And so now your program is going to actually come up with another guess, because if the record is still there, that means it hasn't been solved yet. So you're going to provide based on the record already there. I mean, you can randomly submit, but that won't give you a really high score. In order to get a really good score for homework assignment number 6, that you need to actually leverage the information before you, other students guess, and then your program will actually read all of them in JSON format, of course, and see that how many guess and what's their result. And you actually decide to submit one. That's actually going to help. So in some sense, it's a teamwork, but in some sense, your program is going to interact and the student will come in. I'm actually thinking that if your program will be able to solve, some will be able to win, because remember, now we have a competition, because everybody is actually doing that. It's going to be persistent. By the way, the server is going to be persistent. If it's crashed, I have all the JSON recorded. And you have to win at least some of the work in order for you to get full credit for this.
It's like 5 trials.
What?
When you mean the program has to win in how many trials?
Regardless how many trials. Not just you, right? I mean, there are so many students. There are probably 2,000 work. I will set it up actively. And if you can solve one, if say 1,999 are gone, I'm going to put another different 2,000 words in. So there's a lot of how do I say that, words that's available. So to get the full credit, you need to be able to win sometime. And how do you know you win? You actually will receive the JSON if you win, that you actually guessed it right. And that is your record, you submit that, at least submit one of them, okay? And I have a way to actually find out whether you copy other people's program, but I will talk about that detail later. So, however, if I haven't decided how to do that, I will give some extra credit for those programs who actually contribute a lot to students' win. So sometimes you make a contribution because you actually provide the words. You actually help eliminate a lot of words. You provide the hints for the later students, the program, to actually win. If I actually I have a way to calculate your contribution for each of the guests you provide. And cumulatively, remember I'm looking for that game ID. Cumulatively, if I actually see that this group actually has a really good strategy because it's contribute a lot. And then that particular group will receive extra bonus. Although just let you know if you remember what I said. Number one, I never heard. So extra bonus means extra bonus. It's not mean push people down the curve or something like that. It's just recognize people really group really do well. Okay, so it's not, did I ever tell you I never heard? I use this concept for collaborative, okay, so okay, I better say that a little bit. I thought I always talk about that in the first class. Okay, this is my philosophy of teaching, is that I feel curving, in some sense, is good to help us kind of understand different level of skill set about the student, but curving fundamentally, how do I say that, discourage collaboration. So I have been teaching since 1995. Actually, I've been teaching since 1994. The last year, my PhD thesis, I taught at Columbia for a few courses. Guess which course I taught? C programming. Okay, I was teaching that. I never curved in my career, never curved. It is just my early stage. I have a mentor professor told me the concept of collaborative teaching. We feel in, not necessarily in all the courses, but in programming courses, it's very important to help one another. So I never curve. So you can see that sometimes a lot of students get A in my class, and because I set the bar there, if you can reach that bar, you get an A. I'm okay with that, because I think for you to learn is more important than for me to try to level up which student are actually better than the other, because I feel that is not necessarily the most important purpose of education. The most important education is for you to learn how to help other people to learn. That's actually very important too. Okay, so that's why the bonus is not being calculated whatever curve. I never curve. I'm just looking at the number, and then I basically say, you reach this level of achievement, you should get this grade. Okay, that's just want to clarify that. All right, yeah.
Okay, this question, assignment number 4. So for homework 5, 6 of the final, that's like all of them will have to be done within 2 weeks and a half.
Right.
Is that about right?
Yes, I'm going to say that. So that's why homework 5 is supposed to be very straightforward. Okay, so homework 6 is something which I actually, among all this, I think homework 6 is the most challenging one.
And for homework 2, the due date changed to next week. Is that?
Yes. Yeah. All right. So any other question? So I want to talk a little bit about the final project. So the final project is actually going to be related to your midterm. So your midterm is actually come up with a creative idea about how the car should interact with the motorcycle. So over here, the midterm, you're just doing the design. I'm actually looking at the design, whether the design is innovative. So if your communication about how they can decide whether you should hit this motorcycle or that motorcycle or sacrifice yourself. And now we're actually asking you to think about, well, how should that be decided, and then using the object-oriented modeling to describe that process. So for the midterm, you really need to just draw 3 diagrams. The first diagram is class hierarchy. The second diagram is component hierarchy. The third diagram is what we call the interaction, the function call. So that is individual. You actually come up with an innovation idea, and then I'm going to grade based on the individual innovation contribute to that process. So the final project, you're going to form your team, 3 to 4 students. And you are going to pick, again, essentially going through the same process as you did for your midterm exam. You're doing the midterm, but you can actually probably 3 or 4, if you get together, you can actually probably come up with a better idea. Once you come up with a better idea over here, the difference is that I want you to do an implementation of that. I want you to really see a real C++ object and talk to the real car object. And the other thing is that each of the car is going to be a separate program. Each of the cars is going to be a separate program, which means that you're going to use JSON RPC to actually implement those remote procedure calls, let them talk to each other. And hopefully by this time, this is actually already something pretty straightforward to you, okay? And how do you actually report this? What I want you to do 2 things. because this is going to be likely happen in the final weeks or actually because we don't have a final exam. I want you to do the following. First, you're going to record a video using Zoom or whatever tool you want to present, and the video is going to be with a few terminal windows. Each of the terminal represent the vehicle or object or things like that they're actually running, and then you prepare maybe a couple slides to represent your idea. So you actually talk about idea, you show the demo, and then you record the video, and then you actually submit the video. And we will set the deadline maybe in the middle of the final weeks. That's actually going to be, I will receive that. And the thing is that I need to get your consent. If some of you are, after the grading is done, okay, after the grading is done, if you would like to share this video with other students, you can actually do that. I will provide a platform, or you find other platforms to do that. That's okay. But I'm going to grade your exam based on the video, but also after I watch your video, I haven't decided how I'm going to do that, but I'd like to ask you a few questions. I would like to respond. Okay, and I know we have a 150 student. I calculate it's about 40 group, If I give every group 15 minutes to actually answer a question, we might be able to do that in 2 days or 3 days. So one of the options I'm thinking is just block from Wednesday to Friday of the final weeks and set up a Doodle links with everything. I don't have any other final, so I will just sit there and try to let you sign up and try to interact with you about asking questions about your work, especially if there's something which is I don't understand or I have a concern, I would like to check with you. Okay, if that process sometimes if I realize that some of the video they're so comprehensive, I don't have any question, then I can probably tell you that, hey, I don't need to meet with you. I think I got the idea completely. Okay, and that's basically what's going to happen in this one. Okay, all right. So any question about? Yes, please. The class hierarchy, which represent the inheritance relationship. And the second one is called containment hierarchy, is basically represent which component they're actually included in each of the object or each of the class. So I said that for class hierarchy, you need to draw the graph like what we draw. For containment hierarchy, the best way I recommend, maybe I should mandate this, just write pseudocode. Just say class, motorcycle, and what's in there. Yeah, just write down. And I'm not going to check for your syntax or whatever. It's just check, I understand the component. And the third one is, I call it, what do I call it? Message interaction is about how the objects are interact with each other. Meaning that, for example, the car is going to send alert to the motorcycle, say, hey, I might need to hit you or the other one, and I need some information, and then the motorcycle is going to respond another message, and then they might have a multiple round of interaction over there. Yeah, that's an interaction for two things. One is representing what member function you need to define for your object, right? Because that's the function we're going to call. And the second thing is that whether that sequence of the call of all the member function you design, whether that's actually lead to a decision that's decide whether you're going to hit right or left. So essentially that graph with this two other diagram will have a very transparent picture about why this car is hitting this motorcycle. So that's what we want you to write it down. Okay, not type it down. Write it down in the. Okay, so just a little bit favor I want to ask you, please have a very clean handwriting, okay? Sometime when I grade handwriting, some of your handwriting is so beautiful, so artistic, to a point which I cannot recognize you're writing English or Arabic. Okay, I cannot tell. So okay, just do me a favor, okay, and do your favor as well. All right. Yes. Well, you can use any inheritance you like, but I do want to say that as I emphasis is that I much prefer we only use single inheritance if we can solve the problem, because single inheritance is usually the cleanest and it has the power to solve pretty much. If you want to use either virtual inheritance or multiple inheritance, you better have a good how do I say that, justification for doing that. Yeah, why we need to do that? Yeah.
Single inheritance being just only one parent, or
Yeah, only one parent. Yeah, that's the, to me, that's the limitation. But for example, let me give you an example. We talk about account, right? Say we have an email account and we have a financial account, right? You can say, okay, I want to inherit from the parent, which has both kind of account. That's why I need two accounts. That's in the case of multiple inheritance. But I can actually make two accounts as a component of one of the parent. I can actually sometimes use what do I call it? Containment hierarchy to represent some of the concept to avoid multiple inheritance. I don't know if you understand what I'm saying. For example, I say, let me try to think about a good example. Sometimes I need a really precise example. I cannot get it very nicely. Give me an example. Anybody help me? Give me an example of multiple inheritance. You think that you need to have multiple inheritance. Give me an example.
Person, student, employee.
So
a student can be an employee, or an employee could be a student, and both of them are.
Okay, so we're saying that a person, so who is a parent? Who are the parents?
Okay, so parent is person.
Okay, one is a person.
And then we say we have an employee, but we have a student. The student and the parent of the student is the employee. And
okay, so you're saying that the student is inherit both a person and the employee. You have two. Okay, so I'm also going to ask you help. Can I actually represent those using single inheritance?
we have two copies of student. One is from one parent, the other is from one parent.
Why do I just do this? I can have a component inside employee. I call the person. So all the person perspective is actually included in that component. So employee. Okay. Employee. I mean, an example, I have to think through, but sometimes I can play that trick. So essentially a student is capturing information that's nothing associated with a physical person. It's just a position in the university. I mean, the more difficult example I will use is a faculty, a professor became an administrator, say a dean. So we have administrative staff, we have academic staff, right? Teaching staff, administrative staff, and the professor, they have a 50-year appointment with a dean's office and 50% as a academic title. Then how do I actually represent that? I mean, you can actually do multiple inheritance, but multiple inheritance in that case is not ideal because there is a concept called 50% appointment. It is how these two are mixed. So in that case, it will be good to actually include the appointment as a component inside a professor to say I have an appointment of this, 50% of an appointment of that. And that is in fact, is going to be array or vector. Oh, by the way, I remember what I missed. Somewhere here, I'm actually over here, I'm going to start talking about the concept of a vector, standard C++ template, and those are the topic you will see here as well. Yeah, so far we haven't talked about array, but that is a very interesting topic to talk about array, talk about map. That's all the nice C++ utility for us to handle really nice program. Yeah, I was actually worried about this. Just share with you the other option. I was thinking about this. I think doing distributed Wordle might be a good one. But the other one, which I want to tell you, is have you heard about the concept called letters in the bottle? Have you heard about letters in the bottle? So letters in the bottle, you throw it to the Pacific Ocean. It will travel all the way to New Zealand, and somebody actually pick it up, right? And then what you do, you pick up the letter, and then you write a few things. Oh, I saw your letter. This is nice. And Amen, why don't you think about this way? And then you throw that bottle back to the ocean, and then it will fly. Eventually, people will get it. So the other way to do it, just similar like what we talk about Wordle, is actually implement this in a cyberspace. So if you have some question, like for example, similar to Piazza, or similar to some of the issue, and you have a question about homework assignment number 2, and you write the question, and you put it in the bottle, you throw it into the ocean. And the thing is that now the ocean exercise a concept called social algorithm. So social algorithm is actually try to create the ocean flow. It will flow to the person who can probably best solve that issue. So that is a similar concept. Like right now, we're trying to throw this Wordle, but you can actually throw everything as well. But that's another thing, which is a lot of C++ library will help us to solve problem like that. Okay. All right. Any other question? Yes, please. Can you speak a little bit louder? Sorry. There are 2. I have to fix. I probably placed it wrong. Let me try to fix it. I have no. Wait a minute. Hold on. That's strange. I'll fix it. I must have placed maybe incorrectly all 3 or which that and I have to. But thank you for pointing that out. Okay. All right. If no question, I'm going to start to talk about homework assignment number 3. So just to let you know, let me show you what's the homework assignment number 4. Homework assignment number 4 is like this. Is basically just to let you know, part 1 is for 0 credit. I want to clarify that because I thought this is interesting for students to learn a little bit about performance. So I actually this is related to the array when I talk about pointer. So this part is totally optional. If you have time, you can actually play around with it. But the most important is homework assignment number 4, which I gave you 2 .h file. One represent multi-inheritance.h, one represent virtual inheritance.h, which is represent the example we gave in class, which is work study, and also employee, student, and also the account. And the thing is, I just want you to print the address of each of the components to see the difference between multiple inheritance and virtual inheritance. Okay, now I'm going to homework assignment number 3. So homework assignment number 3 is Little Red Riding Hood Part 2. And is exactly the same thing. And there's two students, exactly those for record. But the thing is that you're going to implement this function called JSON to object. So the format of the object, sorry, it shouldn't be Boolean, it should be bool. So essentially the function prototype, again, is a virtual member function, just like homework 2. Homework 2 is, if you remember homework 2, let me actually bring it up. Homework 2 is here. Homework 2, I asked you to write this function called dump to JSON. Is actually from a C++ object and return the JSON value. So homework 3 is actually take the JSON value as the input parameter. So this is typically uses that you create an object, but that object is a blank object. You just create a person when you create a thing. And then what you do is that you use that JSON value, which previously, this is the output of homework assignment number 2. So essentially 2 and 3, they're supposed to go together. So the return value of this 2 is actually going to be the input value of this JSON2 object. And such that the program will actually recreate exactly the same object as you have here. Okay. All right, so now let's actually look at the example. I am only going to provide you one example for how to do JSON to object. I'm using GPS object as an example. So you can see that over here, this is a GPS.h. And inside GPS.h, you see I have a two function. This is the two function I'm talking about. One is called dump to JSON, one is called JSON to object, that you supposed to implement this already for homework 2, and now homework 3, you're going to implement this one, JSON to object. So let's actually take a look at the implementation of that. The first part is exactly the same, but now I'm actually going to say here is, let me see if I can make it smaller so I can fit everything in one page. Yeah, okay. So this is the code that's actually implement JSON to object and everything. This is actually the answer to that particular class. And then, of course, you need to implement that for every single class. So let me actually tell you a few important components. You can see that almost 50% of the code, I'm actually checking whether the JSON is actually containing the right information. I cannot just blindly accept the information that sometimes people has a misspelling or people has forget about some of the information. So first, I'm actually check whether argjv itself. So argjv is the argument JSON value, is the input argument. And the first part, just check whether is it a null. If it's sometimes you gave me a null object, I don't need to worry about that. I just throw away. Or it's not an object. It's actually a basic type, meaning that it's not a nice JSON format as a JSON object. So first I have to check whether it's a null or is this not an object. If it's not the case, then I'm going to throw away. Okay, the second part is that I'm going to look for attribute. Remember, I want to construct the object. So let's take a look at the GPS dot. So, actually, you know what? Yeah, I can do this. So the thing is that I have a few attributes I need to remember. And in this case, I have two attributes. One is latitude, one is longitude. So therefore, the JSON value might contain something else. Like again, a lot of other things, I'm not interested, but I need to have at least this two. This two are basically give me the basic need for construct the object I care in C++ world. That's why I need to check, hold on. I need to check this 4 lines of code is checking whether those two attributes are actually indeed in the JSON value object, which is arg_JV. So the first thing I did, look at the thing. The first thing I always did is whether it is null. The first thing I will check is whether you do have that particular object. If you don't have that object, then basically I will be gone. Okay, let me actually tell you, if you don't have this 2 line, you directly go for this 2 lines, sometimes you will have segmentation fault. Depending on how the runtime supports implement, because if it's a new object and you try to interpret, is a double. So the second 2 line of that 4 line is checking whether the type is correct. So you not only give me a attribute I want, you also actually have to tell me what kind of data type I'm expecting. Because in C++, I'm actually expecting the latitude and the longitude to be double. That's why I'm actually using this is first I check if it's a null, if it's either one of this is a null or they are not double. Then either one of this situation is actually true, then I'm going to return false. I'm not going to try to do this part because if those things are not done, then this part is going to be dangerous to do that. Okay? Yeah, of course.
Say, okay, the longitude is not provided, but the longitude is. I can still use that as well. Like, why do I have to check if like one of the values is missing? Then
that's a good point. That's a valid point. So it really depending on the development. So if we think the partial information is good enough, then I could potentially include partial information. But for example, if for GPS in the case, I have partial information is dangerous, right? What happens if I'm a DOD contractor, I'm using this traditional missile to somewhere I'm missing one? It's not very nice. Right?
No, yeah, but say as a social, if you have
Right.
a social company, then any data that
Right.
you can see your hands
Right.
on is useful.
Okay. So let me actually tell you the other thing. And thank you for you to ask this question. Have anybody heard about the concept called structural data versus non-structured data? You probably heard about SQL and non-SQL. Have you heard about those terms? SQL, non-SQL. This is actually exactly the same issue. So what is a structured data? Structured data means that every single column is fixed. So you have a table, you have this attribute, meaning that every record has to have everything. But what's non-structured data? Non-structured data means that some of them has only 1 or 5 of the 10 attributes. Some of them have some other thing. And in fact, I don't even restrict what possible attribute you can put into that JSON. So essentially, non-structured is exactly the issue you're dealing with, is that I try to get as much as out as I can, right, to construct object. So that is a big difference between a JSON object and a C++ object, because JSON object is non-structured, where C++ is structured. That's why we have the issue. Okay, going deeper to your question, it has to deal with semantics, because sometimes convert a non-structure to a structure, the conversion need to mandate certain data, I have to have it. If you don't, like GPS, if you don't have a longitude, latitude, and I don't trust that address at all, right? So that is the semantics we need to bridge. But to be honest with you, the question was just asked is so important in today's world. Essentially, you're in the Silicon Valley, you're handling information from a political event, from any kind of scientific event. It's really about what data should be included. in that conversion from the non-structured to structured. And that's actually very practical. That's actually causing a lot of problems. You can see that how many times people drove to the wrong conclusion because they actually didn't select the right feature in the data. And then they actually only look at whatever available. Okay, so this is usually what we say is that sometimes it's not about you don't you get the wrong data. Sometimes it's because you actually miss certain information, and which is totally misinterpret that result. Okay, any other question? All right, so after the check, I mean the check is usually we need to handle, but there is a one basic requirement for C++ programmer, regardless whether we deal with data analytics, is that you need to check enough such that your program won't crash. In fact, I actually can show you the other of my JSON to object. I check about 40 lines before I actually get to the point. Why is that? Because if I miss some of the check, my program is going to causing segmentation fault. That's why I need to check before I dump JSON to the next level. Okay, so after you check, then you actually do this. So then the result is actually really the following really simple is that only this two line is related to JSON to object. The rest is all about check. Only those two lines are related. Because I only have two attributes, I have two lines. So what is that? I actually extract argjv. I extract the latitude. Latitude is a what I call it a key value pairs key, and then I'm actually getting the value. But then I'm using this function, this member function. By the way, this is a member function of JV value. And the member function say as double means that I convert whatever JSON encoding into a C++ double value. And that's going to be a double I actually assign there. And this is the same thing you can assign there. Okay, so let me just show you, because I have 1 minute, I want to show you this one, JSON value. Just tell you that JSON value is really powerful. The first one, JSON CPP, JSON value. I actually shared this link before. You can look at this is a class called JSON value. And it has a bunch of member, but the most important thing is all the public member function. And you can see that it has all this as integer, as unsigned integer, and here is as double. Okay, it basically has everything as object or whatever. It should have as object somewhere, is object. Yeah, you can see that all the function I use is on this page. And it overload pretty much all the operator. And yeah, it's really nice class for you to want to do this kind of conversion between JSON and okay. I'm going to stop here and I'm going to pause. And then after the class, after the break, I'm going to talk about some of the JSON to files. So I always talk about I will run the program for you, of course, continue, but I'm going to show you also, once I use down to JSON, I can actually save the file. And then from the file, I can get back to the program, and then from the program, I will shuffle to the C++ object. So you can do things like a persistent object or object mobility very nicely. Okay, I'm going to pause here for a moment. Okay, so I have this program, it's called JSON to object. I just want to do two things before I close the session. Number one, I want to tell you how to use it. Number two, I want to tell you how to actually deal with file. The first thing is that, okay, now I'm actually going to the homework 4 client dot maybe I will do a client dot CPP, sorry. Okay, you can see that here. Now I have a bunch of GPS object I was created. So now I did one thing is that I save a JSON value. I call it XYZ. And JSON value XYZ is equal to, I will call it GPS home woodland dot dump to JSON. Okay, so this line basically helped me to get a JSON representation about this particular GPS home woodland object. And then what I'm going to do is I'm going to say bool status J is equal to, okay, I know what I'm going to do. I need to actually create a GPS object. I create a GPS object, GPS, ed, YYY. Okay, I just create a empty one. And then I will say is equal to YYY dot JSON to object. And then I just simply put XYZ in there. Okay, so what I did here is that the first line, okay, maybe I just complete the program to here. I just do a return 0 here. And then I'm going to do this. I'm going to do say std cout. The first object is YYY dot dump to JSON. This will give me a nice JSON output. And then say dot to style string. And then at the end, I will say std and line. Okay, so let me actually just explain this. The rest of the code, you don't need to worry for now, because that's actually related to the JSON RPC. But here what I did is that I create the JSON from the GPS home woodland, and then I create an empty GPS object called YYY, and then I actually load the JSON value into this YYY. And after that, I'm actually going to print this out. And I'm also going to print out the original object, which is GPS home woodland dump JSON. And then I'm expecting this too is going to give me exactly the same result. So let me try to make it. And then in this case, I will just say client. That would be good enough. So you can see that it's actually producing exactly the same result, which shows that if these two are the same, that means I can actually flip between JSON world to C++ world and flip from C++ world to JSON world. Okay, I mean, of course, this is a very simple one, but if you write in a recursive way, you can actually make a really complicated object, and they are going to be really equivalent. Okay, and there is one function I'm going to release to you. I will probably talk more when we have a later part of this homework, is this program called ecs36b JSON.cpp. So I just want to tell you what they are, and then later, this will be really handy for you to do anything related to file and JSON together. So this program the first program is a print log. You probably don't have to worry about that. But I want to start to talk about the first program. The first program is called my parse JSON. So what is the my parse JSON? My parse JSON is you actually provide an input string. This is not a JSON. This is a normal string. And then I'm going to actually convert it to a JSON value. So you actually, if you actually write a JSON string in the starting from curly bracket, the key value pair, human readable format, and how do I actually convert that into a real JSON object? And this is a part of the code that's actually going to do that for you. Okay, this is converted a string to a JSON, okay, calling the function called reader parse. That's how you can actually using this to actually be able to build that kind of conversion, this few lines of code. And then you have another program called file to string, which basically say, if you give me a file name, I'm going to convert that file into a string. So the first function is convert string to JSON, and the second function is convert from file to string. So this two functions together is actually giving you the function called file to JSON. So the first function, the second function is the file to string, and then from string to JSON. And this function is directly combine those two to actually include the file to a JSON. So what I did is, you can see here, this is actually pretty simple. Is just basically just call, oh, I actually make mistake. Wait a minute. Yeah, start again. I must using a lot of battery. Cannot believe this is the second time I encounter this. Wait a minute, do they have a battery here? So this shows all the UC Davis professor, we work really hard. We speak too loud. Perfect, okay. So essentially, I think I make a mistake here, is that file to JSON, just call those two functions together, you can do that. I need to fix that. This must be an older version of the code. And a related is the other way. This function is called JSON to file. What I showed you earlier is a file to JSON. But this function is actually JSON to file. So if you have a JSON, you input a JSON, and then I will actually give me a name, and I will actually write that JSON as a string format to that file. So this two function, JSON to file, file to JSON, I use this a lot in my programming development because it helps us to actually easily convert whatever I want. And together with this two function, file to JSON, JSON to file, together with the two functions I asked you to do, dump to JSON and JSON to object, that you can actually just travel every form about the object-oriented world. You can actually convert from file to string, from string to JSON, from JSON to C++. And then you can actually also convert from C++ to string, C++ to JSON, JSON to string, and string to the file. You can actually go both ways, and it's really handy for you to be able to handle things. Okay, so just let you know, there is a facility there you can actually use. Probably you won't need this until you handle homework 5 and homework 6, but I want to provide this code to you as early as possible. Okay. All right, I'm going to stop. And